Ever wondered what the largest known prime number is? A simple question, but one that leads us into a fascinating journey through the world of mathematics. Prime numbers, those unique entities that have intrigued scholars for over 2,000 years, are the key building blocks in the realm of numbers. But the quest for the largest prime number is not a trivial one. It's a challenge that stretches the boundaries of our computational capabilities. Stay with us as we venture into the captivating world of prime numbers. Prime numbers, quite simply, are the building blocks of mathematics. Now, when we say prime, we don't mean it in the sense of being first or main, but rather, in a mathematical context, it has a distinct meaning. So, what exactly are these prime numbers? A prime number is a unique kind of number that has only two distinct positive divisors, 1 and the number itself. In other words, a prime number can be divided without leaving a remainder, only by 1 and by itself. Let's take an example. The number 2 is the smallest prime number, as it can only be divided by 1 and 2. This special property of prime numbers makes them stand out. They're like the atoms of the mathematical world, indivisible and unique. They're the pure essence of multiplication, and you can't break them down any further. Now you might be wondering, why are these prime numbers so important? Well, prime numbers play a pivotal role in various mathematical operations and theories. They are fundamental to number theory because they are the building blocks of whole numbers and important to the encryption algorithms that keep our online transactions secure. They offer a fascinating playground for both amateur and professional mathematicians alike. But primes are not just about division and security, they also have a mysterious side. Despite their basic definition, they pop up in unexpected places and ways in mathematics. Their distribution among the integers is a riddle that mathematicians have been trying to solve for centuries. If you begin counting, you'll find that the primes start out thick but become increasingly rare, a pattern but no apparent formula to predict where the next one will occur. This randomness within order is part of the beauty and fascination of prime numbers. Aren't prime numbers fascinating? And they get even more intriguing when we talk about the largest known one. The largest known prime number, discovered in 2018, is no ordinary number. It's a behemoth in its own right. This colossal figure, known as M82589933, boasts a mind-boggling size with over 24 million digits. If you tried to write it down, you'd run out of ink, paper, and probably patience long before you got to the end. But what makes M82589933 particularly special is not just its size, but its type. It's what we call a Mersenne prime. Now, you might be wondering, what on earth is a Mersenne prime? Well, it's a prime number that can be written in the form 2 circumflex p, one where p is also a prime number. Named after the French mathematician Mersenne, who studied these numbers in the 17th century, Mersenne primes are incredibly rare. In fact, out of the infinite sea of numbers, only 51 Mersenne primes have been discovered so far. The beauty of Mersenne primes lies in their simplicity. Their unique form allows for faster calculations, making them highly sought after in the world of mathematics. They are key players in number theory and cryptography, and are used in creating random number generators, which are crucial in computer science. But don't be fooled by this simplicity. Finding these numbers is no easy feat. It's like searching for a needle in a cosmic haystack. It's a monumental task that requires advanced algorithms, supercomputers, and the collective efforts of thousands of people across the globe. This humongous number with over 24 million digits was not discovered by chance. It was the result of a dedicated search. A search that continues even today as mathematicians and computer scientists alike strive to uncover the next largest prime number, the next Mersenne prime, the next mathematical marvel waiting to be discovered. The discovery of M82589933 is attributed to a unique project known as the Great Internet Mersenne Prime Search, or GIMPS. This extraordinary endeavor is not the work of a single mathematician or a team confined within a lab. Instead, it is the collective effort of countless individuals around the globe, all sharing a common fascination for the enigmas of prime numbers. GIMPS is an exemplar of a distributed computing project. Now, what does that mean? In simple terms, distributed computing is an approach where a complex computational task is divided into smaller, more manageable parts. These parts are then processed separately by different computers, often scattered across the globe, before being reassembled to form the final solution. Imagine a jigsaw puzzle with each piece being solved by a different person. Once all the pieces are completed, they are brought together to reveal the full picture. Similarly, GIMPS harnesses the power of thousands of computers worldwide, each working on a different piece of the prime number puzzle. The goal of GIMPS is simple yet audacious: to discover larger and larger prime numbers, and not just any primes, but Mersenne primes. These are a special category of primes named after the French mathematician Mersenne that take the form of 2 raised to the power of an integer, -1. The search for these colossal numbers is a daunting task. It requires advanced algorithms, sophisticated software, and the immense computational power that only a global network of computers can provide. But why, you may ask, do we need to find bigger prime numbers? Well, prime numbers are akin to the atoms of mathematics. The larger the prime, the deeper we delve into the uncharted territories of mathematics, pushing the boundaries of human knowledge. With the help of thousands of volunteers and their computers, GIMPS is on a mission to uncover even larger prime numbers. The search for prime numbers is no easy task, a statement that succinctly captures the essence of the Herculean effort required in the world of prime numbers. The challenge begins with the sheer size of these numbers. Imagine a number so large it's composed of over 24 million digits. The enormity of these numbers is enough to make one's head spin. It's not just about finding any large number, but finding a large number that is prime. This means it can only be divided by 1 in itself without leaving a remainder. It's a bit like looking for a needle in a haystack, except the haystack is the size of a galaxy and the needle is an atom. To navigate this vast numerical landscape, we need advanced algorithms. These are like the maps and compasses of the prime number world, guiding us through the rough terrain. They are meticulously designed to sieve through the complex web of numbers, systematically identifying those that are prime. But even with the most ingenious algorithms, the task is too immense for a human or a standard computer to handle. Enter supercomputers, the mighty machines capable of performing billions of calculations per second. They tirelessly crunch through the data day and night in search of new prime numbers. It's a daunting task, requiring not only mathematical prowess but also computational power. And so the search for prime numbers becomes a testament to our technological and intellectual capabilities. It's a journey through a universe of numbers, a journey filled with challenges and surprises. Prime numbers, though seemingly simple, hold immense complexity and challenge in their discovery. So there you have it, the largest known prime number and the fascinating journey to its discovery. We've traversed the fascinating world of prime numbers, those unique integers that have only 2 distinct positive divisors. We've marveled at the sheer size of the largest known prime number, M82589933, with its mind-boggling 24 million digits. We've also delved into the remarkable efforts of the great internet, Mersenne Prime Search, or GIMPS. This dedicated project, harnessing the power of distributed computing, has been instrumental in unearthing 17 Mersenne primes, including the largest known prime number. The search for prime numbers is far from over. It's a challenge that continues to push the boundaries of our mathematical knowledge and computational capabilities. But as we've seen, it's a journey filled with discovery, intrigue, and a deeper understanding of the mathematical world around us.